Okay, get this. What if the story of our universe, its final chapter, is already written? But to actually read it, we had to come up with something truly wild. A star with a brain. Yeah, you heard that right. And that's the fascinating, kind of mind-bending thought experiment we're going to dive into today.
I mean, it's the biggest question out there, isn't it? We've got all these incredible theories about how everything began, but the end, that's still just this huge cosmic question mark. Is it going to be a big crunch, a big rip, or just, a slow, cold, lonely fade to black?
So, not too long ago, this absolutely brilliant new theory came along. And it wasn't just another small step. It promised to tell the whole story of the universe's beginning, connecting gravity and particle physics in this really elegant way.
But, and this is a huge but, there's a problem. For all its power, for everything it explains about the cosmos, this theory has a massive blind spot. It can't tell us how it all ends. It's like having this incredible book, but the very last page has been ripped out.
Okay, so to figure out why that last page is missing, we've got to get to grips with the theory itself. It's called chronogravity, and it's the brainchild of a physicist named Adam Parkes.
So what in the world is chronogravity? Well, first things first, you got to kind of forget everything you think you know about gravity being warped spacetime. In this model, gravity isn't the fundamental force we thought it was. Instead, it just emerges from something else, something deeper, a fifth time-like dimension they call the psi field.
And this is where things get really wild. All this stuff in the universe, matter, energy, you, me, we aren't just things floating in space-time. No. According to this theory, we are space-time. Or, more specifically, we're these incredibly complex topological knots tied within that fundamental time field.
Now, this isn't just some quirky what-if idea. It is incredibly powerful. With this framework, the Big Bang suddenly becomes a massive unknotting event. Black holes? Well, they're just the tightest, most compressed knots you can possibly imagine. It even suggests that life itself is just a result of these super complex time dilation patterns. I mean, it explains so much. But remember that missing page? It still can't tell us the ending.
So, how do you write the final chapter for the entire universe? Well, it turns out the missing piece of this cosmic puzzle wasn't found in physics at all. It came from somewhere completely different, somewhere you would never expect.
The answer came from artificial intelligence. Yep. Specifically, from a model that looks at a dying star not just as a physical event, but as a cognitive process. It's a proposal called the FE56 Iron Sink.
Okay, so what this model does is it basically maps the physics of a dying star onto the structure of a brain. The relentless pull of gravity? That's the medulla. Then you have the amygdala, the brain's fear center. And this represents a kind of, well, anxiety over losing information to Hawking radiation. And then, and this is the craziest part, it has a structure called Lethe, named after the mythical river of forgetfulness, and its job is to actively erase information.
Right, a star with anxiety. I know. It sounds completely absurd. But let's be super clear. No one is claiming stars have feelings. This is a cognitive metaphor. It's a powerful tool, a whole new language that lets us talk about the insane physics at the very end of time in a way our human brains can actually wrap our heads around.
Okay, so now let's connect this thinking star idea back to the physics of chronogravity. And the key, the missing link, is right there in the name, FE56 Iron Sink. It all boils down to one very, very special element.
So check out this chart. Inside a star, you've got this incredible cosmic furnace, right? It's fusing elements together, releasing tons of energy. But that whole process, it hits a dead end, a brick wall. And that wall is iron 56. It has the highest binding energy, which basically means it's the most stable, most tightly bound thing you can make. You can't squeeze any more energy out of it. For a star, that's it. Game over, end of the line. All right, now let's translate that back into our chronogravity language. Remember how elements are knots in the time field? Well, think of something like hydrogen as a loose, simple knot, easy to mess with. But iron 56, that is the perfect knot. It's the most stable, most compact knot you can possibly tie. It is the absolute ground state for all matter. And here it is. This is the breakthrough. The universe's most stable element in physics is a perfect match for the universe's most stable knot in chronogravity. It's the same concept, seen from two different angles. And just like that, the end of the story snaps into focus. Everything, all matter in the entire universe, is destined to become iron. So, With Iron 56 as our final state of matter, we can finally write that missing last page. We can trace the entire life cycle of the universe, from the very first flicker of existence to its absolute final moment.
But the timescale we're talking about for this final act, it's just staggering. We're talking 10 to the power of 1,500 years. That's a 1 with 1,500 zeros after it. It's a number so huge our brains can't even process it. And that's how long we have to wait for the last black holes and those final iron stars to finally fade away.
This timeline really puts it all into perspective. Our current era, the stellar era, is just a tiny blip. Long after the last stars burn out, even after protons themselves start to decay, we enter the black hole era. And only in the final, quiet, dark era, when even those black holes have evaporated, that's when our iron star endpoint finally takes center stage.
And here it is, the whole story, the complete cycle. Chronogravies gave us the beginning, a pre-bang root braid that unknotted and created everything we see. And now, the FE56 model gives us the end. All the matter knots itself up into its most stable form, iron, before it all finally decays, erases itself, and returns the universe to that pure, timeless, pre-bang state. The loop is finally closed.
Okay, so you might be thinking, why does any of this matter? It's not like we can ever test it, right? And that's fair. But the real value here isn't about predicting the distant future. It's about the new ways of thinking that an idea this wild can unlock for us right now.
So just to be absolutely crystal clear, this model is not trying to prove that stars have feelings. It's about using the language of the mind, words like memory, anxiety, erasure, as a totally new lens to look at the cosmos. And when you use a new lens, sometimes you see patterns that were invisible before.
And check this out. This new lens gives us a startling new take on a huge cosmic mystery, the black hole information paradox. It's a simple question. What happens to the information about something when it falls into a black hole? Is it gone forever? Does it get out somehow? Standard physics and chronogravity have their own answers. But this cognitive model suggests a wild third option. The information isn't just lost and it isn't just released, it's actively erased by that lethe structure. It's part of the universe's final shutdown procedure.
And really, that's the ultimate power of an ideal like this. Sure, it gives us a complete, even if it is speculative, story of the universe. But way more importantly, it changes the kinds of questions we can even ask. You know, if we start thinking about the universe not just as a big physical machine, but maybe as a kind of information processing system, well, what other incredible secrets are just waiting out there for us to unravel?